Hello everyone, welcome to the all-member meeting and to my talk about Lavadocker. I'm Jan-Simon Moeller. I'm the release manager for AGL and I'm also the lead of the CIAT expert group. If you have questions, feel free to reach out to me either on Freenode or by email. Today I want to give you an introduction to AGL's Lava infrastructure, tell you more about Lavadocker, how we use it in AGL, how you can make use of it at home, and how you can contribute to evolve the AGL infrastructure and show where we want to go next, what needs work, what is going on, and a short outlook. Here you see AGL's CIAT loop from Gerrit. Once a change is submitted, it will be built in Jenkins, and the artifacts are then stored on the download server. And we submit a build job to the Lava scheduler, which will then hand it down to one remote worker, which then does the necessary steps to the device under test. In the end, we feed back into Gerrit to notify the developers. For this, we use Lava. So Lava originates in Linaro. It's the Linaro automated validation architecture. In essence, it's a scheduler to run tasks on real or virtual hardware. Basically, it's a board lab or board farm management system. It works in a distributed environment, so there is a central scheduler and there can be a number of remote workers. It also lets you take away the board management, the board maintenance tasks from the developers. They don't need to have the board on their desk and deal with SD cards and so on. Basically, you have a rack of boards where you can run tests on. In AGL, we use the network boot capabilities, which essentially means we no longer juggle SD cards, which saves a lot of time. Now, yes, there can be the case that you need to test actually booting from SD card. That is possible. There are SD card multiplexers out there that can be used in a job to actually write the file system onto an SD card and then boot from it as well. This is how Lava is set up. We have the scheduler, which can be somewhere in the internet. And down there, we have then a worker, which is the PC that's directly connected to the device under test. Usually that involves serial and network. And of course, we need some way to control the power. Here are a few examples. On the left side, we have 6 beagle bones that are connected together in a lab. On the right, this is the lab for AGL that BayLibre hosts with different devices under test. And essentially, in the end, it will look like this, a stack of boards in a rack that are connected to your worker. Setting up Lava itself is a multi-step process. To simplify this, AGL reuses Lavadocker from kernel CI, and we have our custom boards YAML, which then matches our master and slave labs. Everything is kept in there, including the tokens for reproducibility. So our boards YAML cannot be public, but we can help you getting things set up. The job submission is then done with Lava CLI. That's the command line interface. It's written in Python. You can grab it from pip. So this is rather easy to install. The jobs are YAML, and we have a simple templating kept in Relling scripts that will spit out jobs based on a configuration that we call. So Lava CLI plus a YAML description, which we get out of Relling scripts. So what we need for a lab. A lab needs a worker machine. The most simple case is actually a Pi 4 with a relay head for power control and maybe a powered USB hub, so we do not draw too much power from the Pi. Up to server grade hardware with whatever specs if you attach multiple devices. In any case, we need some sort of power switch or relay board, network relay board, or whatnot. TLDR, we need to control power to the device under test. The device under test itself, of course, or the devices under test, that can be multiple of the same type, that can be multiple of different types. So a worker machine can host multiple. In general, for DOT, we need serial access. This is sort of a hard requirement for most cases. Network connection is a requirement. Usually we have a second network interface on the worker machine, kind of a DOT-only network with an own switch, so we can keep the DOTs separate from the internet or allow them access if we configure that in this way. We need the board to have a bootloader with serial and network support if we do network boot. Things like fast boot is also possible. There are also support for custom firmware loaders. Those are special cases that you can look up in the Lava documentation. For AGL, we also need either an HDMI screen attached or an HDMI jig that emulates a screen. Such jigs, these HDMI plugs, they are available for a couple of bucks, and they emulate the screen resolution settings. So we get kind of the 1080p at whatever hertz back, and the screen gets activated. This is required, for example, for the compositor to come up. No screen size, no resolution, no compositor coming up because no size is known. Lavadocker is the Dockerized version, which can either be set up as a scheduler or as a standalone worker connecting to an existing scheduler. We have an own stable branch that matches our setup on gitautomotivelinux.org/agl/lavadocker, and this matches our master server for convenience. That matches what we run on our master. The master is on lava.automotivelinux.org, so if you want to take a look there, you can browse around. The configuration of Lavadocker. So in case there's a master or a scheduler, you can configure the master, which kind of looks like this in our case, not exactly. And for a slave, for a worker, we do set it up in this way. The usual template is given here, your lab name, the host name of the lab, the remote, which is in our case lavaautomotivelinux.org, the remote user account on the scheduler, the token on the scheduler, the IP of the internal DOT network, in case you have a second network interface just for the devices under test. Coordinator is for multi-device tests, and we expose, for example, SER2net here, which allows us to also telnet to the devices under test serial. In this sample case, we just have a very simple board, which is of type QEMU. There is not a lot of settings down here, but in principle here we set up things like how do we set up a device regarding serial power and so on. Now, if you want to try this at home on your PC, you can easily just check out the sample project, which comes as part of the Git repo. You actually do not have to copy the example down. There is a board YAML already. You call lavalabgen.py, you cd into your output, and in the end you call docker compose build and docker compose up. The simplest setup comes just with a scheduler and a worker, and in the end you open this URL and your Lava is there. We also would like you to contribute to HDL. Especially we are looking for additional boards around IMX8 and Qualcomm, which we could add to our Lava lab. Additional H3, Pi4, BBE, and QEMUs are always welcome, but we also want to expand the reach on boards that we have in the lab. Now, how can you then drive a test on a board that's connected to Lava? Tests are executed using test definitions. Such a test definition is then called as part of the job that's submitted to Lava. AGL has a few test definitions. They are kept on the Git server in Struer's QA test definitions. In essence, it is a description in YAML format and kind of a script that does or calls or executes the test. The assumption in Lava is that the test binary or whatever is needed to run the test is part of the file system and then executed by the scripts. Yes, there are other paradigms, there are other test systems that do bring the test and what's needed to the target. So basically, we do not need a preconditioned file system. Um, that's one approach. It can be done with Lava as well. In our case, in AGL, we just ship what we want to run as well. Here's an example for the metadata file. So there is two things. One is the YAML file, the metadata, and one is the script. The YAML file first. It just comes with some description, and then we have down there the run steps, which kind of execute commands, kind of shell-like commands. There are a couple of wrappers or specially formatted uh, echoes, specially formatted strings that are recognized by the Lava system, and those can be called with the Lava test set wrapper, which issues the echo in the proper way, so it's recognized by Lava. This is the script part. Basically, we export a couple of variables, and in this case, we call PyTest. So PyAGL is a test suite for the AGL services written in Python using the PyTest framework. PyTest itself has support for the Lava style of output, so it will generate the output in a format that Lava recognizes. And in this case, we just condition things, no color, no escape sequences essentially, um, and no pagers. And we do, in this case, tests which are not which do not require any hardware and which do not connect out to the internet. So the next steps, what are to be done for AGL are to extend the test suites. The infra is in place. We worked a lot to get things to a state where we can use it. We have now full graphical support, so we can also do screenshot tests. We have deployed the audio jigs everywhere. We can run the radio tests. And we are working on CAN tests next. And during the coming month, we will also add tests which are specific to the IVI expert group and which are specific to the instrument cluster expert groups based on their requirements, input, and the tests that they contributed. What are the benefits of such a setup? So two main benefits. It's especially nowadays, it's hard to get the hardware in one place. And if the hardware, even if the hardware is in one place, you might not be able to access your office, quote unquote. Lava allows us to provide a Lava worker for remote operation. And we do not need to ship the board. You do not need to be in an office, for example. And that will allow to work and simplify the access. For AGL, it's very important to test the changes, every change to the distro, and any change to an upstream component in an automated way. No SD card juggling is required. We can parallelize the testing and provide fast feedback to our developers. Now, if you have any questions, I will be available now and take your questions through the platform.